Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on October 28, 2025, about 4 days ago. This paper introduces the Agent Data Protocol, a lightweight interlingua that unifies fragmented agent datasets and, when used for supervised fine-tuning, delivers roughly 20% average gains over base models, with highlights like SWE bench verified jumping for QN 2.57b from 0.4% to 20.2%. The paper is titled Agent Data Protocol, Unifying Datasets for Diverse, Effective Fine-Tuning of LLM Agents. And as we'll see later, the implications for model training are quite significant. Alright, the introduction set the problem of fragmented agent data. Figure 1 presents the pipeline that standardizes raw datasets into a single agent data protocol format, so training becomes plug and play. The diagram organizes trajectories as alternating actions and observations, which cover API calls, code actions, messages, text feedback, and rich web states. The right side then routes the unified data into multiple supervised fine-tuning harnesses, showing compatibility without per dataset engineering. Well, Figure 1 laid out the unified pipeline. Table 1 catalogs the training sources that feed it, listing 13 datasets across coding, software engineering, tool use, and web browsing. The variety column flags domains with letters, while counts range from about 1,000 to over 1 million, and sources span manual, synthetic, and rollout. Notably, Orca Agent Instruct contributes roughly 1.0 million synthetic tool use instructions, and Sinatra adds about 100,000 web demos, which underscores the scale and diversity ADP can standardize. So Table 1 set the scale of sources. Figure 2 shows how the protocol turns messy many-to-many conversions into a clean hub and spoke pipeline. The left panel depicts the quadratic burden, where each dataset needs a custom raw to SFT path to every agent harness. The right panel replaces that with one raw to ADP step per dataset and one ADP to SFT script per agent, which makes total effort roughly D plus A. New datasets or agents plug in immediately because the shared ADP hub stays fixed. Alright, the previous figure highlighted the hub and spoke conversion. Table 2 summarizes how the standardized datasets actually differ, which matters because training stability depends on trajectory shape. Average rounds span roughly 1 to 27, with an overall mean near 10. SWE tasks show the longest sequences, while browsing sets stay shorter. Action mix skews 53% API, 24% code, and 23% message overall, and function thought coverage averages about 84%, with mind to web showing none. So, Table 2 highlighted dataset shape differences. Table 5 reports outcomes at the 32B scale. The shaded rows show ADP-tuned models that surpass prior results across agents and benchmarks. On SWE bench verified, QN 2.532B coder instruct reaches about 40% with SWE agent, while OpenHands records about 37%. Web Arena lands near 23%, and Agent Bench OS rises to roughly 35%, which confirms strong gains without domain-specific tweaks. So, Table 5 showcased peak 32B results. Table 6 compares task-specific tuning against mixed ADP data for cross-task transfer. The SWE bench block shows QN 2.57b rising from 1% to 10.4%, while QN 3.8b jumps to 16.6% versus 0.2 or 11% with single domain data. The Web Arena block improves from 16% to 20.1%. The Agent Bench OS block climbs from 21.5% to 25.7%, and the GAIA block moves from 0.6% to 9.1%, which signals broader generalization. Wrapping up, 2 takeaways stand out. A simple agent data protocol turns messy many-to-many converters into a clean hub and spoke flow, slashing engineering from quadratic to linear effort, and the unified data delivers about 20% average gains with strong cross-task transfer. The broader implication is scalable, reproducible agent training. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.